Current and voltage as we are being serenaded by class. Okay. Current and voltage. Electric current is measured in units called amperes or amps, or abbreviated big A for short. 1 amp is a flow of a certain quantity of electricity in 1 second. So the amount of electric current entering a circuit always equals the amount exiting the circuit within that 1 second. So these little guys down here, these little spheres, represent electrons. So you're counting how many electrons pass in this spot in 1 second. So you're counting. It would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and such. So that would give you your amps, the number of electrons passing a certain spot in 1 second. So obviously, the faster they move, the more you're going to have pass in 1 second. The slower it is, the less you're going to have. So it lowers your amps. So when you talk about an amplifier, what does it do?
Makes everything louder. Like if you're playing like guitar, you put it into an amp and it makes it louder. So it makes the voltage higher.
It makes the voltage higher because what is it actually doing? It's making your electrons go faster through that same spot. So you're increasing the amount of electrons passing through the circuit. Okay. Voltage is a measure of electric potential energy, just like height is a measure of gravitational potential energy. Voltage is measured in volts, or abbreviated big V. A voltage difference of 1 volt means 1 amp of current does 1 joule of work in 1 second. Okay, so with all that jargon, what does that indicate that there probably comes along with this? Equations! And we're not doing that, so don't worry about it. We're skipping the math part. My goal for you is to understand the basics of what electricity is, how it functions, and how it's measured, but not actually do the measuring per se. Okay. Okay. A difference in voltage provides the energy that causes a current to flow. So your basic batteries are 1.5 volts, unless you have a 9-volt battery, which obviously is 9 volts. So it has a higher voltage. Okay. So voltage difference causes the currents to flow. So it's sending those electrons around in the path. So you have your positive that it starts off with. It ends at the negative. Voltage can be measured with a multimeter. And you can do this by, and you will be doing this in the lab, so by attaching the probes on a multimeter, you can measure the volts of a battery, and you can also measure the volts that are passing through a wire, depending on what you touch. Okay. I have some rechargeable batteries that I keep putting in my little remote presenter, and my remote presenter is not working. So how do I know if it's the batteries or if it's my remote presenter that's broken? I can check the voltage on the battery and see if my rechargeable battery is actually being charged. And if it says 0, then I know that it's not being charged. But if it says 1.5, then my battery is good. It's my presenter that is bad. So going back to the scientific method, how do you solve a problem? Correct. Amps is just counting the number of electrons that's passing through that circuit.
So is it like the kinetic impact?
It's kind of like how strong did you turn on your faucet?
Oh.
So the more you the more you turn your faucet on, the more electrons are going to pass through because it's higher amps. But you're going to have the same amount of voltage, so your voltage won't change. Does that make sense? You're still having water come out. It's just at what your amps is. It just at what speed is it passing through and coming out.
Out of a faucet? So like when you like
You know, like when you turn on your garden hose and it comes out, just then you get like a little spray. That's like low amperage. And then you turn it on and you crank it up and it like comes out like a fire hose. And that would be a resistor. When you block a garden hose. I have to explain that because she wouldn't be able to hear you.
Is voltage like the total amount of water that there would be in the like you could get out of your faucet?
Exactly.
Okay.
So the voltage is the amount of potential energy. So it would be the amount of water that you could get out of the faucet, and the amperage is just how quickly that water is going to come out. That's good. A battery uses stored chemical energy to create the voltage difference. Now, when we did the squishy circuits, we lined our batteries up in a battery pack next to each other, not stacked on top of each other, because when you stack them on top of each other, you increase the voltage because you're now passing it through all three in that direction versus sharing the voltage. That way you just have more potential energy here because you have more batteries. It's still all 1.5 volts, but when you stack them on top of each other like this, you add it all together and you end up with 4.5 volts. So you're increasing your voltage when you stack batteries versus putting batteries next to each other. So like when you have a toy and you put them in and it's, calls for batteries this way, it's still 1.5 volts. So they doesn't need a lot of volts to work. But obviously if you have to stack them on top of each other and slide them into like a tube, that means that you're increasing the voltage by stacking the batteries. Okay. A pump is like a battery because it brings water from a position of low energy to high energy. So it's taking that stored energy and then it's pumping it to where it needs to go to make that circuit. Is there anything to write down for that? So here it just shows you the same mannerism of our reference to water, of how it flows and goes around, just like the electrons do. Measuring current. If you want to measure current, you must force the current to pass through the meter. So multimeters can measure two types of current: alternating current, which we call it AC, and direct current, which is DC. Not AC/DC, the band. It's alternating current and direct current that we're talking about. And again, red is positive, so it has to go in this direction, and black is negative, so it goes out. Red's in, black's out. Does that make sense? Okay. So when it's hooked up in the pathway, you're measuring current. When you touch it to the battery, the multimeter to the battery, you are measuring voltage. Reminds me of on it's Bolt, not Volt. The dog on is it Underdog? Or Bolt? Bolt. Oh, it's just Bolt. I think Volt. Because he's got the like which makes you think electricity. Really? Okay. The key thing with measuring current. Circuit breakers and fuses are two kinds of devices that protect circuits from too much current. Because you don't want a surge of current coming in, because that's when your TV will blow up or your computer will blow up. And it doesn't like blow up, go boom, and go into pieces. It like blows the electric circuits inside of it and fries them, so they will no longer pass current and won't work. So too much current is bad for electrical devices. So you have things that you put them into, and you have the surge protector strips. That's why they recommend you plugging your computer in, not directly into the wall, because that's not going to protect it if there's a surge of electricity that comes through that cord into your computer. Where a surge protector, it gets that surge, it recognizes too much coming in, it shuts down and doesn't let it get to the computer, and then your computer is safe.
But isn't having too many things plugged in there bad?
When you have too many things plugged into it, it pulls too much and it shuts it down. So obviously they're made to pull as much as they have that many plugs for.
So is that why if like people have too many lights on in the house, they'll blow up?
Exactly. So if you take, depending on what your circuits can handle in your house, and they're wired differently, and that's why, depends, if you pull electricity off of an existing wire and keep making like electrical outlets off that same wire versus running new wires, you're going to end up pulling too much. So if you try to run, like in the kitchen, I do this when you try to run the mixer, the toaster, and all these appliances that pull out the electricity at one time, it's going to pull too much, it's going to blow a fuse. When you blow a fuse or a circuit in your house and it trips, basically when it trips, it's doing what to the circuit? It's stopping it by opening the circuit so that that electricity cannot no longer go through. Because what it's saying is there's something wrong that you need to fix. So a lot of times people will ignore that. You blow a fuse, you go down, you just flip it back on, you get your current, it blows again. It's blowing for a reason, that there's a short circuit or there's a surge of power coming from somewhere, that the wiring is not proper, and bad wiring leads to fires. That's how my house burnt down. As my house, there was a short in the wires. Yes. When I was a freshman in college, my house burnt down from an electrical shortage. We lost everything we owned. Okay. Okay.
Couldn't you just press a button on the electrical thing if you're confused? Like there's like a little red button or a black button. You press it.
Yes. And that's just like on your blow dryer. You have that little red button. Sometimes it'll blow. And that's the safety for if it gets in the water that it's going to like shut off or try to protect you.
Okay. If you have a fire from electrical stuff, how would you do that if there's the surge or whatever that
You don't
helps
use
you
water on
not
it.
like have so much electricity? You know what I mean?
Because it's not at the electrical outlet that it's happening in the wires in your house. So a mouse who got into your walls and ate through your insulation of your wires and broke the wires open caused a short circuit to happen, and then all that insulation around it, it gets hot because all these electrons are fighting each other and short circuiting, creating heat, which can catch it on fire. So it's not necessarily at the outlets where you see it. There's a lot of behind the scenes wires going all through your house. And that's one thing that we did when we built our house. We went in after they did the wiring and we took pictures of all the wirings in the walls, because a lot of people will sometimes go to do remodeling or even just like hanging something in the wall. You can put a nail in the wall and go right through an electric wire, and then you cause problems. Okay. So obviously circuit breakers pop for a reason. The old kind, the fuses, if you go to old houses, they have the little glass fuses that have the metal in them. You can, instead of getting a new fuse to put in there, people used to put pennies in there because pennies were made of copper, and copper is a good conductor. Most of the houses have circuit breakers versus fuse boxes.